Hi there, Professor Monty. Let's talk about finding x and y-intercepts of parabolas. Okay, so remember to find the y-intercept, we just set x equal to 0. And look at this graph. Here's a graph of a parabola, and the y-intercept is where it intersects this line, the y-axis. And notice you have to have an x value of 0. So it's 0 comma something. So to find this, we set x equals 0 and we solve. Similarly, to find the x-intercepts, the y value has to be 0 because we didn't go up or down at all. So we set y equal to 0, and that helps us find the x-intercepts. Let's just look at a couple examples. So find the intercepts of this function. Remember, f of x just means y. So I have y equals x squared minus 4x minus 12. Y-intercept's always really easy to do. So the y-intercept, set x equal to 0, and I get y equals 0 squared minus 4 times 0 minus 12, and that's just y equals negative 12. So the y-intercept is the point x was 0, y was negative 12. And notice I didn't have to do the math. It's always just the constant. And the y-intercept x equals 0 and the x-intercept y equals 0, that's for any graph that you're going to look at. Okay, so anyway, there's the y-intercept. I could have just said, oh, when x is 0, y is negative 12. Boom, I have that one. For the x-intercept, now I set y equals 0. Well, remember f of x is y, so that's just 0 equals x squared minus 4x minus 12. And I'm just solving a quadratic equation. If I can't factor this, or if I don't know how I'll use the quadratic formula, this does factor nicely. It's x minus 6, x minus 2. Those multiply to negative 12 and add to negative 4. So I get x minus 6 equals 0, or add 6 to both sides, x equals 6. X minus 2 equals 0, add 2, x equals 2. So I get two x-intercepts. One is when x is 6, y is 0. And one is when x is 2, y is 0. And so there's my y-intercept and my x-intercepts. You'll never have more than one y-intercept if it's a function, because then it wouldn't pass the vertical line test. Let's look at another one over here. So I've got an equation, again, for the y-intercept, that means x equals 0. So remember, shortcut-wise, it's just going to be the point x is 0, y is negative 1, the constant. There's my y-intercept. And if you want to work it out, y equals negative 3 times 0 squared plus 2 times 0 minus 1. Again, that's just going to be negative 1. So when x is 0, y is negative 1. And then for the x-intercept, again, set y equal to 0. So it's 0 equals negative 3x squared plus 2x minus 1. This one, maybe I don't know how to solve. I don't know how to factor it, so I'm just going to use a quadratic formula. So remember, we get x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so in this case, a is negative 3, b is 2, c is negative 1. When I plug it in, I get x equals negative 2 plus or minus the square root of 2 squared minus 4 times a is negative 3, c is negative 1, all over 2 times a, which is negative 3. So I get negative 2 plus or minus, let's see, this is going to be 4. These negatives cancel to a plus, but then I have another negative, so it's going to be negative 12, all over negative 6. But notice what I get is x equals negative 2 plus or minus the square root of negative 8 over negative 6. And I've got a problem right here. Remember, I can't have a negative under a square root to be a real number. This is actually a complex number. So this is complex. Or you may say imaginary. Imaginary is the proper term. The reason why we can't do this is because that's imaginary. But as soon as you get a negative under the square root there, that means you don't have a y-intercept. Excuse me, an x-intercept in this case. So complex, we'll call it imaginary. That means there's no x-intercepts. So there's no x-intercept. We had the y-intercept here. And what that means, since I have 0, negative 1, it's something like this. I've got 0, negative 1 is my y-intercept. The parabola opens down because it's a negative, it's never going to go up there. So it goes through there. I can find the vertex to draw a good picture of it, but whatever it is, let's see. If we do negative b over 2a, that's going to be negative over negative, so it's positive. So it's going to look something like this. That's why there's no x-intercepts. You see that because you get a negative under the square root. All right, that's the idea. Remember, for any graph, the y-intercept is setting x equal to 0. The x-intercept is setting y equal to 0.